So question 10, it says work out the nth term of the sequence. So if we look at it here, I've written it down first, and then I've found out that all it is take away 3 on each one. So 6 take away 3 is 3, 3 take away 3 is 0. So we first of all, we put down minus 3n. And then we look at the previous number to that, so that would be 9. And that would be like minus 3n plus 9 would be the nth term of that. What I've done is I've just rearranged it to have it 9 take away 3n on this one, but they're both the same. So question 11 is a constructions question. So ABCD is a rectangle with AB is 9 centimeters and BC is 7 centimeters. Shade the region inside the rectangle with the locus of all points that are greater than 4.5 centimeters from C. So we look at, because it says from C, it's from a point, so we get our compass. And we measure 4.5 centimeters. So when we measure 4.5 centimeters, then we can draw our arc there. So anything over this one is more than 4.5 centimeters. So that's that one done. We can tick that one off. So the next one is nearer to B than D. So when we get something like this, it's more or less like a bisector question or a bisector. So basically B and D, so we connect those B and D up with a ruler. So we draw B and D with a ruler and just draw straight across. So now we come to a perpendicular bisector on this one. So that this will mean that split halfway or equally on this. So if we take this one here and we put it on D and we just draw a arc, and this gets opened over halfway of this line. Yep, so just an arc you would draw all the way around so that you're connecting up there. And then you would go to the other side and do not adjust your compass, and you would draw another arc until they cross one another. And when they cross one another, then you would draw a line going through these bits here. So where they cross, you would draw a line through those. And that's your perpendicular bisector. So the question is asking, it has to be nearer to B than D. So this side is nearer to B. And so we're shading in this area here. So question 12 is a trial and improvement question. It says use trial and improvement to solve the equation. Give your answer correct to the 1 decimal place. You must show you're working. So first of all, it doesn't give you any numbers to start off with. So you have to kind of like figure out for yourself which number to start with. So I've started with 2. And what you do with this 2 is you substitute into this expression here. So it's instead of the x, it's going to be 2 cubed. Instead of that's 3 times x. So instead of the x, it's going to be 3 times 2. So 2 cubed take away 3 times 2. When you put that in a calculator, you should get 2 and compare it with the 11. It is too low. So because it's too low, I've moved up one and I've went to 3. So it's doing exactly the same. That would be 3 cubed take away 3 times 3, which is 18. And we compare it with 11 and it's too high. So 2 is too low, 3 is too high. So that means we're going to go in between 2 and 3. And I've picked 2.6. So it's just the same, 2.6 cubed, take away 3 times 2.6, and we get 9.776, which then, compared to 11, is too low. So as we go on, you can see that I've went up to 2.7. We've found out that 2.6 is too low, 2.7 is too high. So that just basically means one of those would be the answer because it's to one decimal place. But to determine which one it is, we have to do 2.65 and do exactly the same here by substituting it in, and we get 10.6596, which is too low. So what I've done is drawn a little diagram here at the bottom, and it's just a little number line type of thing. So you'll have 2.6 at one end, 2.7 and 2.65 in the middle. So we've got too low for 2.6, too low for 2.65 and too high. Because these are too low at this side, then the answer is going to be closer to 2.7. And that's the answer to that one, 2.7. So for question 13, we started off just with this shape S on the question paper. And it says, on the grid above, draw an enlargement of the shape using a scale factor of 1/2 and the centre 0, -1. So that means the enlargement is going to be a bit smaller. It's going to be 2 times smaller because it's 1/2. And if we use the centre 0, -1, we can plot that point there. So we kind of work with this centre of enlargement. So to do this, we take each point on S and we go 1, 2, 3, 4, 5, 6, up and 2 across to get to this point here. So if it's 6 up, we half it, which is 3 up, and if it's 2 across, then it's going to be 1 across. So it's going to be 1, 2, 3, and 1 across. And that is the new point for this one. And we do that with every point here. So if I went to this middle bit here, we'd go up 6, and then we go 1, 2, 3, 4. So we half everything. And so it's 1, 2, 3 instead, and 2 across, and we draw a point. And we do this with every point here. So always remember, we count from the centre of enlargement. This one I have drawn lines. This is just to show, or just to check that I've got it right. So if we draw lines through those points, they all should lead to the centre of enlargement. For question B, if the shape is an area of 20 centimetres squared, what is the area of the enlarged shape? So we know the scale factor is 1/2 for the lengths. How to get the area scale factor is we square 1/2. So when we square 1/2, we do 1 squared and 2 squared. So we square top and bottom of that fraction. So that becomes 1/4. So the scale factor of the area is 1/4. And we'll find that what that means is it's 20 divided by 4 on that. So if S is an area of 20 centimetres squared, it's going to be 4 times smaller, the area. So it's 20 divided by 4, which is 5 centimetres squared. Question 14 is direct proportion. So S is directly proportional to the square of V. So that means V squared. When V is equal to 20, S is equal to 250. Express S in terms of V. So I started with S is directly proportional to V squared. I take this sign out and replace it with an equal sign, and then a constant crops up. So S equals K V squared. They've given us 2 numbers here, so we can work out what K is. So all we do is take those 2 numbers and substitute it into here. But what I've done initially is move things around. I've flipped that around and then moved the V squared across. So what I've got is K equals S over V squared. So as you can see, instead of S equals KV squared, I've done KV squared equals S. And then I've done S is divided by V squared. Then I can substitute everything in, which is 250 over 20 squared. S is 250, V is 20, so that would be 20 squared. When we work that out, it's 5 over 8. Now this time I haven't changed it to a decimal. You could do if you wanted to, but this I've just left it as a decimal. This next part, or I left it as a fraction. So this next part is you take the S equals K V squared and you substitute the K part of it in. So 5 over 8 is substituted in to this formula, and that is the answer to that. When it means S in terms of V, it's S equals, and V should be in the actual answer. Question 15 is a simultaneous equation question. So a bag contains 60 coins. Each coin in the bag is either 20p coin or a 50p coin. The total value of the coins in the bag is £22.80. Work out how many of each coin is in the bag. A solution by trial improvement will not be accepted. So this one's a simultaneous equation. So first of all, I've kind of labelled each one as X would be the 20p coins and Y would be the 50p coins. So first of all, we know if we add all the coins up, they should equal 60 coins. So that's X and Y. X plus Y should equal 60. The next part of it is we've done the 20p coins, so the amount of 20p coins plus the amount of 50p coins should add up to £22.80. So I'll put this in pence because sometimes it's easier to work with in pence. So now we've got it set up here. So now we're trying to figure out, do we get rid of the X or do we get rid of the Y? So for this one here is, I've done 2x plus 5y equals 228. Now this equation 2, you can see that I've put divided by 10. This kind of makes it easier. You don't have to do this, but it kind of makes it easier to work out in a way. So you can see everything has got a multiple of 10. It's got zeros at the end. So I can make it easier by dividing by 10. So now I've got 2x plus 5y equals 228. So that I've just changed that. And then we have this one here. You can see 2x plus 2y equals 120. I've decided to get rid of the x's. So if I multiply the first equation by 2, that's 2 times x is 2x, 2y, and then 120. And then I can take those two equations away. So 2x take away 2x is gone. 5y take away 2y is going to be 3y. And 228 take away 120 is 108. So then it's 108 divided by 3, which is 36. So the next step is basically I sub into equation 1, the 36. So that would just mean that x plus 36, because that's the y, equals 60. And then we'll do 60 take away 36, which is 24. So now we've got x is 24 and y is 36. And that's your two. Question 16, it says make t the subject of j equals the square root of tr. So the first one I've done, I've written it down as it is, so j equals the square root of tr. And what I've done here is I've swapped it around. You don't have to do it, but I have done it for this one. So we've done this, instead of j equals the square root of tr, I've done the square root of tr is equal to j. Now to get rid of this square root, so when the square root gets moved across, it becomes a square. So it's tr equals j squared. Next it's j squared divided by r on this. So the final answer is basically t equals j squared over r.